Alright, boys and girls, welcome back to the drive-thru. We're back from spring break 2019, that's right, and we're almost done with Algebra 2 videos. This is 12.5. This makes sense. It's a cool little lesson. I don't think I've ever taught it this way before, but it does make total sense. Okay, first we need to remember all of the geometric transformations. So, like, if we took a triangle and we shifted it right, it would not change shape or size, it would just change location. That would be a horizontal shift. We could also shift it vertically. Okay, we can do a dilation, so if we took a triangle, we could dilate it, and it would be in the same ratio, with the same angles, the same shape, but a different size. We could do a rotation. Sometimes it's easier to have. So, I don't know, I think we're going to focus on counterclockwise rotations. That's against the way that, so that would be a 90-degree counterclockwise rotation, right? Yep. And we could have reflections. So if I took this triangle and reflected it over that line, it would look like that. It would be a horizontal translation. If I took this triangle and reflected it over this line, it would look like that, vertical translation. So that's a little review about geometric transformations. Now we're going to take care of how to use matrices to do this for the easy ones. So let's graph our quadrilateral. A is at 0, 0. V is at 1, 3. E is at 3, 5. And S is at -1, -2. Ugh, I made these up, and now I hate this shape. But none of these are collinear, so it is indeed a shape. It looks like that. Okay? Okay. Alright, we can do this. So how would we shift this shape 3 units to the right and 5 units down? Well, here's how you would do it with matrices. Assume this matrix to be x here and y there. And we have the point 0, 0, 1, 3, 3, 5, and -1, -2. And if we just wanted to go, let's see, right 3, we would add 3. If we want to go down 5, we would subtract 5. And we need to do that to every one. But this is how you got to understand computers do this. So you might be asking yourself, why in the world do I care? I would just do that in my head. I don't need matrices. But you might need to teach a computer how to adjust shapes, rotate them, make them bigger, make them smaller, and that's what we're trying to do there. So notice, our answer is going to be 3, -5, 4, -2, 6, 0, and 2, -7. So now I'll put these on there, and so 3, -5, 4, -2, 6, 0, and 2, -7. And notice, we've got the exact same shape. Okay? So how can we dilate the figure? We would just do 2 times the original if we wanted to make it 2 times bigger. And so we would do 2 times 0, 1, 3, -1, 0, 3, 5, -2. And you get This is doubling each entry. And this will be a dilation. So we get the point 0, 0. We'll do this in green. And the point 2, comma 6. And the point 6, comma 10. 2, 4, 6, 2, 4, 6, 8, 10. And the point negative 2, negative 4. And notice you get one that's twice as big as the original. Okay? Alright. So now, these are the more tricky ones, because you actually have to do matrix, not scalar multiplication, but matrix multiplication. So if you want to rotate it 90 degrees counterclockwise, all of these are counterclockwise, you're going to multiply it by the matrix 0, 1, negative 1, 0. And you're not going to have to memorize these. This one is negative 1, 0, 0, negative 1. That's how you rotate it 180 degrees. This one is 0, 1, negative 1, 0. And the book actually lists a 360 degrees, but hopefully you remember this as the unit matrix, meaning when we multiply it by this, it's going to give us exactly what we started with. Oh my gosh. ViewSonic. And rotating something by 360 degrees is another great way of getting it right back to where it started. So let's take a new shape. Let's take a look at a new shape, because I hated that old shape. And this time I'm actually going to pick my shape. And then so we've got the point 1, comma 0, 0, comma 6, negative 3, comma 4, 1, comma 0. It does not matter what order I write these down in, as long as they match up with their little partner. So I got to have the x and the y's match up. We're going to multiply this. Let's see, what do we want to do? 270 by 1, 0, 0, 1. Row by column. Let's see, let me just do some review. Row by column. This is a 2 by 3. Row. No, there's 3 uh-oh, pause. Aha. See, this is a 2 by 3. We're going to multiply it by a 2 by 2, and we can't do that. So I need to left-hand multiply it by that. I told you I'd never done this before, or never taught it before. So we're going to left-hand multiply it by 0, negative 1, 1, 0. And now we got a 2 by 2 by a 2 by 3, so the result will be 2 by 3. That's what we're looking for. Row by column. 0 times 1 plus 1 times 0 is 0. Negative 1 times 1 plus 0 is negative 1. Okay, 0 times negative 3. 0 times negative 3, negative 1 times 4 is negative 4. Nope, that should be a positive 4. Positive 4, excuse me. Down here, negative 1 times negative 3 is positive 3, plus 0 is 3. 0 times 0 plus 1 times 6 is 6. Negative 1 times 0 plus 0. Let's see how that goes. 0, negative 1. 4, comma 3. And 6, comma 0. And notice, Yes, we have created an exact 270-degree rotation. So this point here has gone 3/4 of a circle to get to there. That's pretty sweet. Love it. Okay? You can also use matrix multiplication to reflect a matrix. And we're not even going to do an example here. I'm just going to give you guys these reflections. If you want to reflect it across the x-axis, 1, 0, 0, -1. If you want to reflect it across the y-axis, -1, 0, 0, 1. If you want to reflect it across the line, y equals x, well, that's the red line. This is y equals 1x. This is y equals -1x. So the red line would be 0, 1, 1, 0. And if you're, blue. If you're going to reflect it across the line y equals -x, you go 0, -1, -1, 0. That should be enough to get you started. Quick little video. We got one left. Hope you guys have a great day. Boom!